Time to take a trip to outer space and have one breathtaking look at all the amazing findings from the James Webb Telescope.
The James Webb Telescope uncovered artificial lights on Proxima B. Researchers have discovered some peculiar signals coming from the solar system closest to our own. It turns out that the signal originates from Planet Proxima B. The best minds in space exploration are baffled by the artificial lights. However, what do these lights actually do? Could this be the final puzzle piece we need to find sentient life? Is there a whole civilization right here next door? Join us as we solve the puzzle of Proxima B's artificial lighting. A signal was found coming from Proxima Centauri toward the end of 2020, located only 4 light-years distant. Proxima Centauri is our nearest neighbor star. To ensure that the signal is not simply an echo of our own civilization, which is frequently what they turn out to be, a team of experts is still carefully analyzing it. So, let's examine the planets in Proxima Centauri directly to determine if the solar system contains sentient life. Oh, and by the way, we are about to reveal some information that no one has ever heard about before. If you want to know the latest secret in space discovery, make sure to stick around to the end of the video. The brightness from Earth's night side is the most clear indication from space that intelligent life exists on the planet. We have a problem with the light that our cities emit that can be seen from space. The telescopes of today's age lack the power to detect the lights from other solar systems. The capabilities of the upcoming telescope generation, which is already in the planning stages, are being tested by researchers. $10 billion, and a couple of decades later, the James Webb Telescope was born. This telescope is so advanced that it can even view 50 million years in the past, before the Big Bang. That's a lot when compared to the 13.8 billion years of our history. However, it is currently very difficult to detect a speck of light on an exoplanet. On the planet's dark side, if the planet burns brightly enough, we might be able to observe if another civilization has turned on its lights. A new investigation into the ability to detect artificial lights on Proxima Centauri B has been sparked by the potential existence of techno-signals from Alpha Centauri. The planet appears to fit multiple criteria for harboring intelligent life based on what we now know, making it a potential possibility. With new tools, especially the James Webb Space Telescope, we can hope to learn a great deal more about this world because it is in the habitable zone of its star. Recent research also points to the launch of LUVIOR, or a big UV optical IR surveyor, a multi-wavelength space-based observatory. According to Harvard researchers Elisa Tabor and Avi Loeb, a planet like Proxima B would need artificial illumination to support a sophisticated culture in order for civilizations to form around nearby stars. A planet that is constantly tilted so that one side faces the sun and the other side is always under the shadow is said to be tidally locked. It's not an absurd idea, given that we recently noticed a strange signal coming from this planet. There are a few ways to identify the presence of alien technology on another world. For instance, a vast constellation of satellites or the light of a far-off planet wave may be visible to us. With the growing number of satellites that we launch into orbit, the same things that are happening on Earth are also occurring there. These technological signs may be created by natural occurrences, such as orbiting debris or comet impact, but atmospheric pollution from nuclear war may be detected. The natural light of stars is different from artificial illumination. The results of the experiment, conducted by researchers Tabor and Loeb in 2021, using the Webb telescope's long-range high-resolution pictures, were not great because the telescope was not yet completely operational. The Proxima B planet, which is the only confirmed planet in the Proxima Centauri system and is positioned in the star's habitable zone 4.25 light-years away, is the target of the Webb telescope. A rocky planet called Proxima B is located in the Proxima Centauri M-class red dwarf's habitable zone. That only makes up 12% of the mass of our Sun. Proxima B, on the other hand, has a radius that is 1.3 times larger and is around 1.6 Earth masses heavier than our planet. In just 11.2 days, it completes an orbit around Proxima Centauri, merely covering 7 million kilometers of distance. That represents less than 5% of the distance that the Earth travels around the Sun. The night side of our planet is absolutely dark at 0% and is equally brilliant at 100%, according to Tabor and Loeb, who scaled artificial illumination reflected from the day side of our planet on a scale from 0 to 100%. But since the type of light utilized by the fictitious civilization on Proxima B is thought to be similar to LEDs on Earth, which have distinct artificial properties, this is not a possibility in the case of Proxima Centauri. What has been revealed by the amount of light that has been discovered thus far? In other words, the Webb telescope might detect the artificial illumination with 85% certainty if Proxima B's artificial night-side illumination equals 5% of the natural day-side illumination. Webb's detection rate would increase to 95% if it were to achieve 9%, though. You might be thinking that 5% illumination isn't that much, but keep in mind that the light we're referring to comes from a star 20 times fainter than our own, Proxima Centauri. That is similar to lighting a candle and setting floodlights next to it. However, even so much light is substantial on a cosmic scale. In contrast, only 0.001% of solar illumination is absorbed by Earth's atmosphere. In other words, the Webb telescope wouldn't be able to detect a civilization on Proxima B that is as illuminated as our own. In order for that scenario to be realistic, the lights would need to be 5,000 times brighter. Proxima B is tidally locked because of how tightly it orbits its host star. The planet's dark side is where intelligent life is most likely to exist. It must have made significant investments in its lighting system for such to be viable. Another theory is that light might be reflected onto the planet's night side using extremely bright orbiting mirrors. Our telescopes would be able to see if this were the case. According to Tabor and Loeb's findings, additional telescopes in the future, like LUVIOR or a huge UV optical infrared surveyor, may be even better at recognizing the glow of an extraterrestrial civilization than the Webb telescope. We might not require 5% of the dayside illumination to recognize objects with almost flawless precision. Just a few days after Tabor and Loeb's study was publicized, Thomas Beatty of the Department of Astronomy at the University of Tucson justified that with those numbers, Beatty reviewed both LUVA and HALBEX, also known as the Habitable Exoplanets Observatory, to better understand how these telescopes will detect city lights on Proxima B, as well as planets orbiting stars out to a distance of 30 parsecs, or PC. With missions to catalog and directly scan exoplanets set to debut in 2035, LUVOR and HAVEX are around 3.26 light-years away from Earth. Therefore, there is still a long way to go. On a number of star systems with known planets such as Proxima B, as well as hypothetical Earth-like planets around G, K, and M-class stars, Beatty employed virtual replicas of LUVOR and HAVEX observatories. A portion of the planet's surface was also made urban by BD. The more urbanization there is, the brighter the planet's night side is. This model's representation of natural lighting mimics the high-pressure sodium streetlights that reflect off of concrete surfaces and are the most prevalent lights on Earth. These lights also have a distinct spectrum from natural starlight. Thus, the variables are 1. The planet's distance from Earth, 2. Its degree of urbanization, and finally, the kind of star it is orbiting. To gather enough light pouring through the void to determine the object, the virtual scopes are photographed for at least 100 hours. Only about 0.05% of the surface of the Earth is urbanized. If someone were to look at us through a telescope from Proxima Centauri, they wouldn't be able to see us. We might be able to view a distant civilization more clearly if there were a higher percentage of urbanization, say 100%. But what does 100% urbanization mean exactly? It is what is known as an ecumenopolis. On this urban planet, a single enormous city spans the entire surface. Although it might sound like a nerdy science fiction deal, it is likely that a highly developed civilization might entirely enclose its planet in an endless urban landscape. Even our existing telescopes will have little trouble detecting a planet like this. Earlier in this video, I said I'm going to share with you some information that no one has ever heard of before. You will automatically be one of the very first people to get this news. The rumors go that NASA is secretly working on a successor for the James Webb Space Telescope. Despite how amazing the JWST's capabilities are, NASA is constantly looking ahead. Even now, with the JWST being live for just over a year now, NASA is already building the superior observatory that will succeed the Webb. This new telescope, in contrast to the ones now in use, is made to take pictures of vast areas of the sky at once, enabling researchers to search for extremely rare and even time-variable events. This newly produced masterpiece will be named after a woman, which is also known as Mother of Hubble, and that was the first female executive ever at NASA throughout the 1960s and 1970s. Therefore, the new telescope will be named the Nancy Grace Roman Telescope. NASA plans to bring the telescope to orbit with the help of SpaceX's Falcon Heavy rocket at the end of 2026. Until then, we have to stick to the surprises that the James Webb Telescope has to bring us. That brings us to the end of the video. We appreciate you watching the video. What do you think about Proxima B's artificial lighting? If you like this, I'm sure you'd love the next video as much as this one. Feel free to take a look.